Hello students, welcome to our new class. This class is on some mathematical problems on chapter number 7, which is waves and sound. And I am your subject teacher, Noman Muttaki. I am a lecturer of Department of Physics of Milestone College. So students, there is some mathematical problems, and here is problem number 1, which is the wavelength of a sound which is produced by an object in air is 20 centimeter. If the velocity of the sound in air is 340 meter per second, find the frequency and time period of the object. So here is the solution. We have to use this equation V is equal to F lambda for solving this problem, because you can see there is the velocity which is 340 meter per second, which is V actually, and here is 20 centimeter, which is wavelength. That means lambda. This is the value of lambda, and this is the value of 340 meter per second, which is velocity. So by using these tools, we can find the frequency of the wave, which is F. So this is the procedure. We can write this equation also like this way: F lambda is equal to V by changing the side. Here we have found the wavelength lambda is equal to 20 centimeter. We must convert this to meter by dividing by 100, and we got 0.2 meter, and the velocity as given the stem is 340 meter per second. So we have to calculate the value of F and T means the time period. So by writing this line, F is equal to V by lambda, and using the value of V and lambda, which is 340 and 0.2, we got 1700. 1700 is the frequency of this wave. So this is another point, which is F is equal to 1 by T. You know, there is a inversely proportional relation between frequency and time period. So I can write F is equal to 1 by T. We have got already the value of the frequency. So we can write this equation by also this way: T is equal to 1 by F, and by putting the value of frequency, which is 1700, we got the value 5.88 into 10 to the power minus 4. This is the value of time. This is problem number 2, and there is another problem, which is problem number 3. The problem number 2 is frequency of a sound is 1200 hertz at a temperature of 30 degrees centigrade. What will be the wavelength of the sound, or what will be the wavelength of the sound? Okay, you should keep your mind that when the temperature increases, the velocity of the sound also increased, and when the temperature decreases, then the velocity will decrease, because the temperature and velocity are not inversely, actually proportionally related. That means when the temperature will increase, then the velocity must be increased. So there is the calculation for velocity at the temperature of 30 degree. There is the temperature 30 degrees centigrade. So I have written that here the velocity of sound at 30 degrees centigrade temperature is 332 plus 0.6 multiplied by 30. As you know, 0.6 is the value. It means that for 1 degree centigrade temperature increase, the increase of velocity of sound is 0.6 meter per second. As the temperature is 30 degrees centigrade here, so you have to multiply the 0.6 by 30, and the 332 means the 0 degree centigrade temperature, the velocity of sound. You can write there 330 also. 330 or 332 is a value of the velocity of sound at 0 degree centigrade temperature. So the calculation for 30 degree centigrade temperature will be 332 or 330 plus 0.6 multiplied by 30. And the temperature we got is, and the velocity we got 350 meter per second. This is the velocity of the sound at 30 degree centigrade temperature, and the frequency as given is 1200 hertz, which is 1200 hertz. And by using the equation V is equal to F lambda, we can write also L lambda is equal to V by F by changing this form, and by putting the value 350 and 1200, we got 0.291 meter. This is the wavelength of the wave. Let's go with the problem number 3. which is find the distance between source and reflector. That means we are going to talk about a mathematical problem on echo, to hear an echo at 30 degrees centigrade temperature. This calculation is very common to you, or very known to you, because we have already discussed on our previous math. The velocity of the sound at 30 degrees centigrade temperature is 332, or 330 plus 0.6 into 30 is equal to 350 meter per second. And you have to calculate the distance between the source and reflector. There must be a distance between the source and reflector, and the minimum distance is 16.6 to hear an echo. We know that. So we will go with the equation d is equal to vt by 2. This is the equation we already discussed on it in our previous lectures. That d is equal to vt by 2 is the equation for an echo. Here d is the distance between the source and the reflector, and v is the velocity of the sound. As there is the velocity 350 meter per second, we have to put the value replacement of v, and t is the time. What is t? T means the minimum time to create for an echo, which is 0.1 second. I have written there t is equal to 0.1 second. We know that the persistence period of time. So 0.1 second multiplied by 350 divided by 2 is equal to 17.5 meter. This is the distance between the force, not so force actually, this is the distance between the source and the reflector. So students, here in this slide we are going to talk about some new equations. uh, let's go with problem number 4. There hanged a stone of mass 10 gram from a 1 meter long string. What will be the time period of that string? For this chapter, we know the equation of time period, which is t is equal to 1 by f. F is the frequency, but in this question there is no frequency. There is only length, which is 1 meter, and mass of the stone, which is 10 gram. By using these tools, we have to calculate the value of time period. But by using the equation t is equal to 1 by f, we can't solve this problem. So that we are going to use another equation, which is t is equal to 2 pi into root over L by G. So students, here we have got the length, which is L is equal to 1 meter, and acceleration due to gravity, this is very known value, 9.8 meter per second square. We have to calculate the value of t, capital T. So by putting the value of pi, which is 3.1416 L and G, we got the 2. So T is the time period of the stone. So problem number 5, this is another problem which is very innovative problem. V1 by V2 equal to root over T1 by T2. We are going to use this equation, and this is the problem. At a certain place, the temperature in winter season is 10 degrees centigrade and velocity of sound is 332 meter per second. That means at 10 degrees centigrade temperature, the velocity is 332 meter per second. If the temperature is raised to 30 degrees centigrade in the summer, what will the velocity of the sound? That means you have got two seasons. The description of the temperature and the sound velocity of two seasons are 10 degrees centigrade and one of 30 degrees centigrade. You are going to calculate the value of the velocity of the sound of the summer. uh, like these problems, we have to use this equation v1 by v2 equal to root over t1 by t2. Here the first temperature, which is of winter, is 10 degrees centigrade. We must convert this to Kelvin by adding 273, and the second temperature is 30 degrees centigrade, which is of the summer, and by adding 273, this is the value in Kelvin, 303. The velocity of sound as given the stem is 332 meter per second, and we have to calculate the value of summer, which is v2 is equal to what? So v1 by v2 equal to root over t1 by t2. This is the equation, and by putting the values of t1, t2 and v1, we got the value velocity of the sound wave in summer is 343 meter per second. This is very important problem. You must solve it and practice at your home. Students, this is problem number 6, and this is very important problem in your test paper or in your book. There are many problems like this, and this is a transverse wave, as as shown in our slide. This is a transverse wave, and this is the time period and amplitude horizontally. Horizontally there is time period, and vertically we shown there the amplitude. there is a distance of 2 centimeter. Let's go with the problem. Calculate the velocity of the wave. Velocity of the wave. For doing this math, we are going to use this equation v is equal to f lambda. That means f is the frequency and lambda is the wavelength. We have to know the value of frequency and the value of lambda. So in this figure there is no frequency, there is only time period, but we know time period and velocity, frequency, there is a relation. These two are inversely proportional. That means f is equal to 1 by t, as I have written there, f is equal to 1 by t. So the time period line shows that there is a dot shows 4 and there is a dot shows 8. Let's calculate. You have to calculate like this: 1 from the starting point, 1 2 3 4, 1 2 3 4. This 4 means by doing a complete oscillation of the complete oscillation, the wave travels this distance. By doing this 4, 1 2 3 4, by doing this 4, the wave creating particle makes a wave of this distance. So from this to this there is a time period which is 4, and this is the time period of this wave for a complete oscillation, which is 4 seconds. So the value of capital T is 4. 1 by 4 means 0.25 hertz. This is the frequency of our wave, and we must know the value of lambda. Let's talk about the lambda by doing the same thing: 1 2 3 4, but there is no distance in this 4, or at this point there is no distance from the starting point, but 1 2 3 4 makes a wavelength, and this 1 2 makes the half of lambda. That means the half of the wavelength. That means we can write lambda plus lambda by 2. That means 1 2 3 4 is a lambda, and 1 2 is another lambda by 2. That means half of lambda makes a distance of 2 centimeter. By doing this calculation, we got the equation value of lambda, which is 1.33 centimeter. This is the wavelength, and we have to convert this by dividing it by 100, which is 0.0133 meter. This is the velocity of the, or this is the wavelength in meter. We know the equation. This is our equation: v is equal to f lambda, and by putting the value of f and lambda from previous calculation, we got the value of the velocity 0.003325 meter per second. This is the procedure of doing this math. This math is very important also. Dear student, this is a creative question. We must read the question carefully. The frequency of Anika's vocal cord. Anika is a person. Her vocal cord's frequency is 700 hertz. She calls a boatman who stays at the middle of the river. Anika hears echo of her created sound due to the reflection from the other side of the river after 1.6 seconds. That means she has heard the echo after 1.6 second. We know the minimum required time is 0.1 second, and 1.6 second is more than 0.1 second. So the echo can be heard here. The velocity of the sound of that time is 350 meter per second. The first question is calculate the wavelength of the sound created by Anika. That means we have to calculate lambda. Wavelength means lambda. So there is a hint for this question. Solution C, hint: use the equation v is equal to f lambda. By using this equation we can solve this problem. We are going to calculate the value of lambda, but we have the value of velocity and frequency as the stem, as the given stem. F is equal to 700 hertz and v means the 350. By putting this value you can easily solve this question, and the answer will be 0.5 meter. So please discuss about the next question, which is for D. Will the boatman hear the echo of the sound of Anika? Will the boatman hear the echo of the sound of Anika? The boatman is not the creator of the sound. Anika was the source of the sound. So you have to read the question again carefully. The frequency of Anika's vocal cord is 700 hertz. She calls a boatman who stays at the middle of the river. At the middle of the river. Okay, let's go with the problem or the solution. The time taken by the sound wave to create echo is 1.6 seconds. As the value is given in the stem, this is the required time, or this is the time of echo, 1.6 second. So the distance between Anika and the opposite side of the river is, why this line is written, because uh, Anika is the source of the sound and the reflector was at the opposite of the river. So you have to calculate the distance between Anika, means the source, and the reflector. So the distance between the source, Anika means source, and the reflector means the opposite side, is d is equal to vt by 2. As you know, this is the equation for echo. D means the distance, v means the velocity. The velocity is 350 meter per second. T is the required time, which is 1.6 divided by t. The velocity, the value is 280 meter. That means this is the distance between the source and the reflector, which is 280 meter. Now listen very carefully. As the boatman was at the middle of the river, that means at the middle of this distance 280 meter, that means the distance between the boatman and the reflector was or is 140 meter, and the needed distance for minimum distance for creating an echo is 16.6 meter, and 140 meter, that means the half of 280 means 140 is enough for creating an echo. As the boatman is at the middle of the river, means 140 meter from Anika, or the boatman was 150 meter away from the reflector, so he will hear the echo. Dear students, this is a creative question number 2. This is a stamp. Actually, this is not a written stamp. This is a figure, which is your stamp. And as you can see, there is a source. S means the source, and there is a reflector, which is R, and there is a point of position of any person or anything is P. And the distance between the source and the position of person is 18 meter, and the temperature of that place is 30 degrees centigrade. This is the stamp for this question. And the first question is, find out the distance between S and R. Means we are going to, or we have to calculate the distance between the source and reflector, but there is only a hint of a temperature which is 30 degrees centigrade, and a distance of S and P is 18 meter. So go with the solution. What is the solution? If the sound is produced at P, it will travel to R and reflect back to P. The temperature of the day is 30 degrees centigrade. Means now we are considering that the sound, if the sound is produced from this position, the P, then the sound will go through this way and it will come back from R, and this is the distance of PR, and the temperature is 30 degrees centigrade. Now we can write this, the velocity of the wave at 30 degrees centigrade temperature, v is equal to 332 plus 0.6 into or multiplied by 30. This calculation is very common to us. We can do this calculation very easily, and the value is 350 meter per second. That means now we know the velocity of the sound at 30 degrees centigrade temperature, which is 350 meter per second. And we are now going to calculate the distance between P and R, and we suppose that the P is the source of the sound for this math only. If one can hear an echo, the time interval will be 0.1 second. As you know, this is the persistence period of time. This is a required time for hearing an echo, which is 0.1 second. We can write this equation, d is equal to vt by t, as this is the equation of echo. What is d? D means the distance, and for this math we are considering the distance P and R. So d means PR. We are going to calculate the distance of PR. So we have written this, that d is equal to PR, and the value of v means 350 and t means 0.1, dividing by 2 equal to 17.5 meter. That means the distance between P and R is 17.5, and there is another distance between S and P, which is 18. You have to uh, do this sum, which is SP par plus PR. SP plus PR means SR. SP plus PR means SR. So 18 plus 17.5 is equal to 35.5. This is the distance between source and reflector. So students, the next question will be very easy for you. Is it possible to hear the echo at position P? Is it possible to hear the echo at position P? That means, let's there is a person standing on P, is it possible for him to hear the echo? By doing the calculation on C, we got that the distance between the P and R is 17.5 meter, and as we know, the minimum distance for hearing echo is 16.6 meter. So the distance, which is 17.5, is more than 16.6, so it is very easy for P to hear the echo. Let's go with the mathematical solution. Here SR means 35.5, SR means the total distance, and SP means 18. So what is the distance between P and R? P and R means SR minus SP. SR minus SP. SR means 35.5, SP means 18, and this subtraction, the result of the subtraction is 17.5 meter. By mistake, I have written there plus. There you should use equal sign, equal 17 meter. That means from this equation we got that the distance between P and R, that means the person and the reflector, is 17.5 meter, and this calculation we have solved in our previous math also. Again, at 30 degree centigrade temperature, to hear the echo at position P, the minimum distance between the source and reflector has to be D is equal to Vt by 2. This is very known equation. So by putting the values, we got the value 17.5. Since the distance between P and R is 17.5, this is more than 16.5, more than the minimum distance. The echo will be heard at position P. So students, this is your homework. You should do this maths, solve the board questions C and D also given below. Rajshahi board 2015, Dhaka board 2015, Jashore board 2015, and Dinajpur board 2015. Thank you very much.